Hello dear students, welcome to the Microwave Engineering Basics course. I am your course instructor, Amit Havdar, Department of Tripoli of World University of Bangladesh. Objectives of this course: to provide the basic theory pertaining to microwaves and other high-frequency devices and subsystems, to examine some of its applications to modern communication systems. Motivations: there are some practical reasons why we want to study this, and there are some intellectual reasons. The practical reasons, that is, it is very useful, it's a fundamental knowledge and increasing important, because microwave engineering has its importance that has been increasing day by day. Some practical reasons are now energy and power generation and transmission in telecommunications applications and other emerging applications. The intellectual reasons, that it's very vigorous, elegant and challenging. Laws of electromagnetic waves have certain beauty about them that can be appreciated by those who understand them on an aesthetic level. Course description. First we have to learn about the lumped circuit theory, then the transmission line theory, after that the electromagnetic field and wave theory, then microwave circuit theory. These two theories are both connected to each other. Then we find the three things: waveguides, the part that the wave transmits through the transmitter to receiver, and the resonators, whether the wave will create, that means the microwave sources, and the antennas. There will be receiving antennas and transmitting antennas. Microwave engineering. Microwave engineering is an engineering and design of communication or navigation systems in the microwave frequency range. That means it works in microwave frequency range. Here is figure 1. We have stated that the electromagnetic spectrum here. Here we can find the microwaves positioned in the wavelength 1 meter to the 10 to the power minus 3 meters, and the frequency ranges from 3 into 10 to the power 8 to 3 into 10 to the power 11. That means it is from the megahertz to gigahertz range. The frequency is denoted in the upper side of the plot, and the wavelength is denoted in the lower side, at the bottom of the plot. Applications. Microwave engineering applications are widely used in microwave ovens, radar, satellite communication, dual broadcast satellite or DBS system, television, personal communication systems. What are microwaves? As we know that frequency is equal to the velocity of light divided by the wavelength, and velocity of light is a constant value, that is 3 into 10 to the power 8 meter per second, and if wavelength changes, the frequency changes, and the velocity of light it remains constant. Microwaves, the waves are ranges from 30 centimeter to 1 centimeter. They are known as centimeter waves, and by this calculation we can get the frequency out of it. That's 1 gigahertz, 30 gigahertz for 1 centimeter, 30 centimeter for 1 gigahertz. 1 giga is known for 10 to the power 9. It's pretty much important that we know. The millimeter waves, that are from 10 millimeters to 1 millimeter, that are known as millimeter waves. What are microwaves? As we see here, there is a wavelength that has been drawn here. That's a wave. 1 lambda is equal to 360 degree. That means a total wavelength crosses, the angle will be 360 degree. Electrical length is equal to physical length divided by wavelength expressed in lambda. That is a relationship between electrical length and physical length. The phase delay will be twice pi electrical length. In radio frequency, The frequency is 10 kilohertz. The radio frequency, the wavelength is pretty much broader, it is 3000 meter. In microwave, 10 gigahertz high frequency ranges, we will get it really shorter wavelength, that is 3 centimeter. So the electrical length is 0.33 lambda. That is the formula finding the electrical length of microwaves, and the phase delay will be 118.8 degree. That is a very large phase delay, and we have to combat with the phase delay. Electrically long means the phase of a voltage or current that changes significantly over the physical extent of the device. And we will learn from the next lectures that it is dependent on the skin effect. Dear students, now we will learn that IEEE microwave frequency bands. Look at here, there are the frequency ranges stated here: high frequency band, very high frequency band, ultra high frequency band, and LSCX, KU, K band, and KA band. And there are also millimeter and sub-millimeter band. That is known as the millimeter and sub-millimeter because of their wavelength. But they are very much high frequency, and all the ranges are stated here in the gigahertz. Most probably from 300 megahertz to 300 gigahertz, that is the range of the microwave frequency bands. The high frequency, very high frequency, and ultra high frequency are used for the broadcasting applications, and the LSC band, X band, KU band, K band, and K band are practically used in the satellite communication bands, and also some military application bands are there. The millimeter, sub-millimeter are broadly used in military applications, military communication. X band is also used for this purpose. Microwave systems. A microwave system normally consists of a transmitter, subsystem, including a microwave oscillator, waveguides that will guide through the wave from the source to the antenna, transmitting antenna, and the receiver. Here use the receiver horn antenna, transmitting horn antenna. That includes the receiving antenna, transmission line, and waveguide will take the wave from the receiver, and there are some waveguide termination point has been given there. Output oscilloscope to measure the power of the wave, and crystal mount was used to adjust the wave of the receiver. Maxwell's equation. It's very important to know the Maxwell's equation, electromagnetic wave theory, to understand the basic of microwave engineering. In electrodynamics, Maxwell's equations are a set of 4 equations that describe the behavior of both the electric and magnetic fields as well as their interaction with matter. Maxwell's 4 equations express. First equation expresses how electric charges produce electric field, Gauss's law. The absence of magnetic monopoles, how currents and changing electric fields produces magnetic fields, Ampere's law, and how changing magnetic fields produce electric fields, that is Faraday's law of induction. Electrodynamics before Maxwell. There are 4 laws: Gauss's law, second law has no name, third law is Faraday's law, fourth law is named as Ampere's circuital law. There are the 3 laws here. First of all, we have to look upon the Gauss's law. It's pretty much known to us. Divergence of electric field is equal to the surface charge density. That's not surface charge, it's volume charge density. It's charge density basically divided by the epsilon naught. Epsilon naught means the permittivity of air, and the divergence of magnetic field is equal to 0, and the curl of electric field is equal to the rate of change of magnetic field, that is popularly known as Faraday's law. How much flux has been cut, then the electromagnetic force will come out to it, and the curl of magnetic field will produce the permeability and current density. It multiplies in these two. Features of microwave engineering. There's increased antenna gain, more bandwidth directly related to data rate can be realized at higher frequencies, high capacity satellite and terrestrial communication link, effective radar system. As it has high frequency, it has increased antenna gain, and for this we know it has higher bandwidth, more bandwidth, and the capacity of satellite and terrestrial communication links are pretty much effectively used by the microwave engineering, and it is used also in effective radar system. Various molecular, atomic and nuclear resonances occur at microwave frequencies. So in some of the sensors we use the microwave frequencies, and there are also in medical science we use microwave resonance imaging too. Microwave applications. The majority of today's applications of RF and microwave technology are to wireless networking and communication systems, wireless security systems, radar systems, environmental remote sensing, and medical systems. Wireless communications. In wireless communications, there are some applications for long distance telephone calls, Bluetooth, WiMAX operations, outdoor broadcasting transmissions, broadcast auxiliary services, remote pickup unit, studio or transmitter link, direct broadcast satellite, DBS, personal communication system, PCSS, wireless local area network, WLANs, cellular video systems, automobile pollution avoidance systems, military and radar. Radars to detect the range and speed of the target, sonar applications, air traffic control, weather forecasting, navigations of ships, mine sweeping applications, speed limits enforcement, military uses microwave frequencies for communications and for the above mentioned applications. In medical applications, monitoring heartbeat, lung water detection, tumor detection, regional hyperthermia, therapeutic applications, local heating, angioplasty, microwave tomography, microwave acoustic imaging. In commercial uses, burglar alarms, garage door openers, police speed detectors, identification by contact methods, by non-contact methods, cell phones, pagers, wireless LANs, satellite television, XM radio, motion detectors, remote sensing, organs. Thanks to all. And please like and subscribe to know more about microwave engineering and next tutorials. Please share it and also support me and give your valuable comments that how I can enhance it.